Who asked you with WebTech? Doing a video on ballistics, firearms, and that sort of thing, and some musings on the subject. In the past, on this channel and on other channels, you can see people discussing or even demonstrating the usage of a simple metal pipe to demonstrate a peculiarity about firearms, specifically shotguns. The pressure rating for and the potential of danger for any particular cartridge is often not based on its caliber or foot-pound rating of impact or any of that. It's just based on surface area of the cartridge, how much constriction or not, how much pressure could build up. Basically, it's based on whatever the pressure is. And if you're not aware of it, standard water pipe is also referred to as black iron pipe. Dozens of names, but one of the other names it has is gas pipe or steam pipe. That should give you a clue. Pipe that is very large diameter generally has a harder time containing an absolute pressure level, like 1,000 pounds per square inch or whatever. Now there's this weird sweet spot based on how thick the wall of the pipe is. If the pipe is really, really big and it has the same thickness as something that's small, that's actually a higher rupture capacity because it contains more total volume of material that's under pressure. And 100 other things. This is obviously engineeringly wrong. But anyway, you can look up not the static pressure level, but the burst pressure level for pipe. It's usually much, much higher. Working pressure is based on continually applying pressure. The burst pressure for 3/4 inch pipe is very nearly, if you get the conventional Schedule 40 pipe, very nearly what you would get out of a shotgun. Now, one of the for the actual pressure level. But that's also not paying attention to the fact that the tube, the long tube, the majority of the tube's length, that's a certain diameter, is smaller than the cartridge in a normal shotgun. But if you use a piece of pipe very often, but not always, the pipe has a bigger diameter inside, which reduces the pressure danger. And people very often don't want to hear that. Now, this is another thing that you, again, don't do this, but some varieties of PVC pipe are just barely at the range where they will tolerate being used as a shotgun barrel. There's a video that was up where someone proved this. It still blew up. It blew up after 6 shots, but it worked a couple of times. Now, obviously, if it's low temperature or if it's worn, it's going to blow up. And obviously, you don't do these things. But this does mean that you can get away with using relatively weak material as long as there's no real change in diameter. In fact, it may be better if it doesn't change at all. So the diameter of a shotgun shell, if you're not aware of it, at the base is about 0.8 inches. I say about because you have to measure each one of them, and there's some history to this. Let's go into that really quickly here. SAAMI, the SAAMI specifications, is based on a voluntary environment for people to contribute standards from the gun industry, ammunition industry, and users for them to create standards or at least create a guideline for things. It's a voluntary system, mostly because it works well. This is the reason now that a 1.75-inch long shotgun shell, called a mini shell, that's been around for decades, has actually been added to the standard for shotgun shells. It doesn't mention anything other than they've acknowledged it. But that's an example of something that can evolve with the industry. The SAAMI standard for what is called a 12-gauge shotgun's bore, aka the diameter throughout the majority of the barrel. Towards the end of it, it can be constricted or even blown open like an old blunderbuss. And the chamber is obviously not the same size as the interior normally, but it works out to a calculated number versus the real world. The SAAMI specification uses 0.725 inches. Now that's, if you're not aware of what 0.725 inches is, that works out to 72.5 caliber. That's big, yes, but the actual number is supposed to be 72.9 caliber if you do a calculation. The calculation on the Wikipedia page is absolutely accurate. It's based on a standard. Now, the standard is based on the diameter of a specific weight of unalloyed, pure, soft lead ball, making it into a sphere and using 1/12 of a pound as 12 gauge. Now, pure soft lead, or most elements, not all of them, if you melt them, they go from a liquid to a solid rapidly. They also go from solid to liquid rapidly, relatively speaking. And there's a contraction of it. They change volume they take up very, very slightly when you do that. And lead is very poor at pouring into a mold sometimes. We now use a slightly less, lower melting point temperature, easy molding alloy using tin, antimony, and other things. Now, this is a lot like solders. If you use a pure element, it'll have an absolute temperature where it becomes liquid or solid at. And then there's this skewing effect when you mix in an element that melts at a lower temperature. Sometimes, even if both of them are melted at a higher temperature, they'll form a lower temperature melt material. This is an alloy. That also means that technically it'll take up more space. So suddenly it goes from 72.9 caliber to 73 easily. The approximation I use when I discuss these is it's a 73 caliber smoothbore weapon if it's a shotgun by standard. But again, SAAMI says it's 72.5, which doesn't make any damn sense unless you're dealing with something more dense, like tungsten inside of the lead. So let's move on. The Wikipedia definition says anything from 18 to 20 millimeter inner diameter, or 71 to 79 caliber. You're not aware of what .79 or 79 caliber is. That's the mouth of the shotgun shell itself, meaning a water pipe. The nominal diameter is 73 caliber, or 18.5 millimeter, depending on the page you're looking at. SAAMI specification page 20 to 21, or the PDF file page 2728, specifies from 2015 to 2019 the standard for a shotgun shell 12 gauge is 72.5 caliber. It's 72.4 to 74.5 caliber range. But they have an absolute number for only one thing. And of course, it's going to be totally for lead, right? 72.7 caliber for the groove depth and 71.9 for lands in a rifled barrel. Basically, 72 to 73 caliber is the rifled barrel. And it's actually just slightly too small to be an accurate dimension for firing a real slug through. The idea is that it squeezes it into these different dimensions and creates a good seal, and it allows the rifling to hang onto a very soft lead ball and spin it and fire it out the barrel. What actually is done by the industry? Well, let's go through the range. Now, Schedule 80, 3/4 inch black iron steam or pressure pipe, gas pipe. 0.75 is the number it's used. It actually is the size that gives you something close. It's 0.724 inches inner diameter, or 74.2 caliber. Very close to, well, nowhere near this, right? Well, here we go. Benelli shotguns, these are regular bore diameters, again, through the majority of the bore. They can have any bore. They can have a bore that squeezes, it can change diameter, it can jug choke, chicken choke, whatever, but let's do their diameter they declare. Benellis are 72.5 caliber. 72.6 caliber for Beretta Serio Plus. Remingtons are 73 flat, just like Beretta Optima Plus. Well, no, they're actually 73.3. The Browning Invictor is also 73.3. Then there's 73.6 for Perazzi, and 73.9, 74 caliber, for Ruger Red Label. Winchester Select and Supremes are 74 caliber, and Browning Invictor Plus again, Invictor Plus, is 74. 74.2 is the black iron pipe. Well, okay, what's bigger than that? Mossberg, 75 caliber, flat, for one version, and another Mossberg is 77.4. Why? The point of a shotgun is that, well, muzzle of a shotgun. The point of a shotgun is that it's supposed to fire shot and do something. And to get rid of a lot of problems with it, instead of using some ideal of what the bore diameter is supposed to be, they looked at what people were actually packaging in shotgun shells. It doesn't matter if you're shooting birds or shooting clays or defending yourself, Mossberg, The bore has to do a certain thing for a certain job. So they figured out that to have whatever effect they wanted, whether it's buckshot for shooting deer, birdshot for shooting pheasant, long-range high bird versus low, shooting through scrap and scrub, blowing a hole in a tree, I don't know what they're talking about here, or making it a slug bore and basically making it according to SAAMI, a 72 to 73 caliber rifle. The bore diameters have to change based on the job that's being done. They'll all technically fire whatever you throw down the barrel, and you'll notice the smallest one, Benelli, is 72.5 caliber. Literally, the SAAMI standard is the lowest end of it. Maybe it's based on not assuming that you have the right bore diameter for anything might jam down the choke, or the forcing cone, or the barrel, or just be able to fit in the chamber. Maybe they just made all of this way so that it would be really difficult to blow the guns up. Or, again, special purposes. Now, a little bit about diameters and chambers. 10 gauge versus 20 gauge. 0.775 inches versus 0.615 inch. What's the difference? Well, those are examples, again, because it's gauge. That's based on having something half as heavy or twice as heavy, depending on which way you're going, as the other one, and making a sphere out of it. So what did these diameters come out with? Well, what's the cube root of 2, and what's the cube root of 1/2? You end up with it being, if you're going from 10 gauge to, from a 20 gauge to a 10 gauge, see, I got it mixed up. You're going to end up increasing the diameter of your bore 26%. If you're going the other way, to making a smaller bore, that's a mathematical doubling in gauge, you're going to be going down about 20% almost. I mean, it's a little over 20% reduction in diameter. 12 gauge and 24 gauge, hypothetically. 0.729 versus 0.579. Now I'm going to talk about muzzle velocity. An example that is used is the 3 dram equivalent 12 gauge shotgun shell throwing 1 1/8 ounce of shot, or whatever, as 1,250 feet per second or something like that. The dram equivalent is whatever propellant you'd have to put in that's different that would give you the same rate through the same barrel, through the same test conditions. At 100 yards, that would be a delay time, because it's going that speed, of about 0.24 seconds. And that would be resulting, if gravity was the only thing you were paying attention to, of a drop of a little under 1 foot at 100 yards, or 300 feet away. What else can affect this? Well, obviously with shotguns you can do all sorts of crazy things. What if you're firing an actual spherical ball through a real diameter for it? One of the things was to do perpendicular rifling. You'd make the top of the barrel have bumps in it, maybe even making the ball look like a golf ball, that would cause it to backspin and come out the barrel, and it would do, instead of doing a curve like that where it falls to the ground, it curves up and then curves back down. So somewhere along the line you're going to have several different points, maybe 3 or 4, where you're hitting exactly where you're aiming at different points. Now, to bring up something else completely useless. Paper shotgun shells in the old days were a standard. The standard included the idea of you'd find out the bore diameter of whatever barrel you had, wrap paper around a stick for the same diameter so that the inside of the shotgun shell was the same as the bore diameter, whatever the caliber was, or in this case, gauge. And you build up the paper until it jam fit into the chamber for the whatever you were firing, slug, shot, rocks, whatever. Now, later on we had metallic cartridges, making basically a big bullet, and also plastic cartridges. Now, instead of you having this sort of situation where this is the layer of the shell material, this is your chamber, and this is the bore diameter, and it would match and it would slide very smoothly from the shell into the bore, we had really thin stuff to where it was doing a jump like that. So you had to have a forcing cone to it. Now, at one point or another, the chamber might have changed size, or bore changed size, because people were using shells that were made for a completely different arrangement. This is the reason, synopsis, for all of these differences in diameters. They're not stable, they're not consistent. And this is the reason SAAMI picked such a weird, completely wrong number of 72.5 caliber instead of almost 73. Thanks for watching. Have a good day. Good luck with all that.